Okay, this is the 1-1A set notation, set interval and inequality notations, as well as domain and range notes. And the domain and range part will come later on in the video. So some important vocabulary words to look at, remember. Set means a collection or a group of data. So that could be a group of numbers, a group of people, group of basically any kind of group that you're putting together. An element is one single item within that set. So if you had a group of your friends, 5 friends, one of those people would be an element in that group, in that set of groups or that set. A subset is a smaller pullout from the larger set. So let's say you had 10 people in the room and you pull 5 people out into a separate group. That would create 2 separate subgroups within that group of 10. An empty set is one in which there are no elements. It is designated with a what looks like an O, but it has a slash through it. It is not a 0, okay? So an empty set means that there is literally nothing there. It's like empty space. A finite set has a limited number of elements. So if you are looking at the amount of time it takes you to get from one place to another, the finite element would be the amount of the most time you could manage to get there. You couldn't go any but more or any, but you could go less, back to 0. So it's kind of like a small range. And an infinite set means that there is unlimited number of elements. There is no limit to what you can do. So this is where we get the idea of infinity. So set notation is something new you haven't seen. It uses brackets and lists all of the elements in the set. So an example is a bracket, which is this funny looking swirly thing. And then you would list out all of the letters of the alphabet. Or you could do a bracket listing all of the even numbers in the number line. Now, if you say positive even numbers, then that could be going on forever. There's no stopping it. Or if you wanted a specific number of even numbers up to a certain number, then you would list just those specific numbers like 2, 4, 6, 8, 10. If you're wanting all the even numbers between 0 and 10, then 0, 2, 4, 6, 8, 10 would be the ones that you would list. Inequality notation is something you are familiar with. It uses the inequality symbols to show relationships. The less than sign, greater than sign, less than or equal to, greater than or equal to, and not equal to. So an example is x is less than 2 or x is greater than or equal to 5. Generally, we do write it in this form where you have x first. However, it is important to remember that these can be reversed. So it would have been to say x is less than 2, you can write it in a different way saying 2 is greater than x, where the mouth of the inequality will always eat whatever the bigger number was. So in this case, the biggest number was 2, it will always be eaten by the inequality, even if we flip it over, making it 2 greater than x. Another inequality example is where x is between two numbers. So -1 is less than or equal to 0, less than or equal to x is less than 2. So that basically means that you can pick -1 as an answer. You can pick 0, 1, and everything all the way up on the number line to 2, but not 2. So you can pick 1.99999, and that's fine, but 2.0 is not available as an option. So here's some example U-turns. These you're going to answer in Edpuzzle, and I will show you the answer afterward. Infinite interval, the word infinite interval is a keyword you want to look for. And then you also want to look for the word inequality. We want to express it as an inequality. So infinite interval means that at some point you're going to have an infinity sign, either on the left or the right. Or you're going to have something that indicates that it goes to infinity. Less than or greater than, less than or equal to, or greater than or equal to indicates it goes somewhere towards infinity. The inequality sign tells us we're using those symbols, that less than, greater than, or equal to. greater than or less than or equal to. So for the first one, which one is this? Well, let's see. It starts at infinity, negative infinity, and stops at 4. So how would we write that as an inequality? It would be either x is less than or equal to 4 because it starts at 4, it stops at 4 basically. That's the biggest number you have, so that's why the greater than sign faces the 4, and it goes all the way down to an arrow, which means it keeps on going towards x, which this is what the less than part of the inequality sign tells us. And again, you can flip that over by saying that 4 is our biggest number, everything else is less than x. Generally, we do like our inequalities to look like the first version of the statement, but be aware this is just as legit and you will see that on tests. Okay, for our second one, we have an open hole at 4 and then it going bigger than 4 all the way to infinity. So open holes are the less than or greater than sign. And then again, it's pointing towards infinity. So is this growing or getting smaller? It is x is greater than 4. See, x is the smallest, or x is over here where the arrow is, and 4 is the smallest one you have. That's why that's where the stopping point is. So here, x, the first one, x was where the highest number was, or I mean, 4 was the highest number. In this case, 4 is the lowest number. And again, you can flip it over. 4 is less than x. So again, the opening always eats the bigger number. Whether it's facing on one side or the other, it's the same. Okay, interval notation is a new notation that you have not seen or may not have seen. It uses parentheses and brackets to show relationships. So a parenthesis obviously is this version. This means that it is less than. Open parenthesis on the other side means that it is greater than. If it is a bracket, this is a solid wall, think of it as a wall, we're a stopping point. This means less than or equal to. So everything up to that point, that is where you would have a closed hole. And then closed hole on the other side would be greater than or equal to. So an example that you might see is parenthesis, negative infinity. We put parentheses on negative infinity except on Schoology because it has issues. But that basically means that negative infinity is undefined. You can call it any number you want. There's always something smaller than it. So that's the idea. So that's why it's an open hole. An open, but that really translate these two together translates into an actual arrow on your graph. Comma 2. So it's saying you can start at an arrow, stop at 2, here at 2, we have an open hole. And then U here means that there is a skipping going on in the graph where it stopped at 2. Everything between 2 and 5, there is nothing there. It's open space. And then at 5 again, it starts over. And in this case, because it is a bracket, it is a solid hole at 5, a solid dot at 5, and then it goes again to infinity, which means it is a arrow. Wish this thing would stop popping up. So the last example is -1 to 2, where -1 is a bracket and 2 is a open hole. So that means it's a dot at -1 and a open hole at 2. So every x is everything between that, or it could be a y is everything between that, depending on which axes you're looking at. So the one problem with interval notation is it does not give us an indicator of which particular variable we're looking at. Are we looking at the domain or are we looking at the range? Interval notation doesn't tell us that. So when we're doing our answers, we have to be very careful to make sure that we're matching our interval notation to the correct variable that we're trying to talk about. Both set notation and interval inequality notation, however, does tell us the variable. So we actually can see who and what we're talking about. With interval notation, we cannot. Okay, so here's your turn. Again, we're looking at the interval notation. Here's a finite that tells that there's a starting and stopping point, no arrows, so no infinities. Interval notation tells us we're looking for something that has a parenthesis or a bracket or a combination thereof. So on the first one, we're starting at -2 and going to 3. So which of these four indicates that inequality? And that is closed hole -2 bracket to 3 closed hole bracket. And on the second one, again, we're going from -2 to 3, but this time we have an open hole to a closed hole. So which of the remaining three options is this inequality? And it is -2 parenthesis on that side to 3 bracket because that's a closed hole. Okay, so some notations to remember. Description of the interval. If it is all real numbers from A to B, including A and B, that is an interval that is finite. An inequality that would look like that would be A is less than or equal to X or less than or equal to B. Again, this means because they're including is the key word there, A and B, that means that there's an equal sign on both because there's a closed hole on both A and B. Set notation would look like this. We're talking about x such, the line means such that, so x such that A is less than or equal to X is less than or equal to B. If you notice that set notation looks very similar to inequality notation, except for this leading information, which tells us what are we looking at. It actually is telling us that we're looking at the set of X, and out of that set, we're looking at the subset that is this. So here's our main set, such that, and then here's our subset. That's how you actually read it. And then inequality is bracket A, comma, B, bracket. So everything from A to B, and then because we have brackets, it's including A and B. The second one is all real numbers greater than A. So this is an infinite interval because it is saying greater than, but it did not have a second stopping point like the first one did. See, they had an A and B. This time it only has an A. So A is greater than A. Set notation is X is such that X is greater than A. So out of all of the possible X's in the world, you're only picking all the X's that are bigger than but not equal to A. And then A is the starting point, so and it was not included, so it's parentheses going to all things bigger than A, which is infinity. All real numbers less than or equal to A or greater than B. So here's an or. The word or is that U that we talked about earlier. So it is an infinite because there are two, it's talking about things going one direction and things going the other direction. And we'll see that here. So X is less than or equal to A. That's where the first part of it says, or it's X is greater than B. So wherever A is, A could be at 1 and B could be at 2, but between 1 and 2, there's nothing there. That's the idea. So again, X is your main, all out of all X's, any X that's smaller than and equal to A, which is 1, say 1, or everything that's bigger than B. So if B was 2, B would have an open hole, but everything that's bigger than 2 would be colored in, would be shaded because it's bigger than B, including 2.011 and etc. etc. And then in inequality, here's that U again, negative infinity to A inclusive, U meaning there's a hole there, skip over between everything between A and B, and then put an open hole at B and start over and shade everything to infinity. Okay, your third turn is a problem is Madeline is making a graph to illustrate the number of $10 teddy bears that can be purchased with some amount of money. Which of the following represents the domain of this scenario? So one is it could be negative infinity to infinity, or what we call all real numbers. The second one is set notation. It's a little bit more complicated than we've actually shown, but it basically means the same thing. Again, it's saying that out of all the x's, that's what this first part of it says, x being all x's in real numbers, we want x's that are bigger than or equal to 0. And the third one says out of all x's, we want x's that are greater than but not equal to 0. And then the fourth one says in interval notation, um, x is included all the way up to infinity. So think about it logically. How many number of teddy bears can be bought? Can you buy 0 teddy bears? Yes or no? That'll determine whether or not it's an equal to or not equal to. Is there any limit to the amount you could buy? Well, depends on how much money you have, obviously, but we're assuming that these people are billionaires, zillionaires, whatever, and so they have unlimited amount of money and they can buy as many teddy bears as they want. So which of these four actually tells those two pieces of information? That it can or cannot start at 0, depending on what you think is correct, and that it can go or forever and amen. Okay, so the correct answer is both 2 and 4. These are two different ways of saying the same information. That X can start at 0 because you can obviously not buy any teddy bears at all. That's cool. If you have no money, you can't buy anything, right? Or you can go up to infinity, assuming you have infinite amount of money to use. Okay, so the next thing we're going to talk about is domain and range. For domain, we remember the and range. We're going to remember two different like mnemonics to help us remember all of the little clues that will remind us when you're looking at domain and when you're looking at range. For domain, it's Dixie, and for range, it's Royd. So domain for D for domain, I for input because the domain is your inputs into your equation. X values are your inputs into the equation. So you put in the X and you get something out. When you put in an X, that is part of the domain. And then I for independent. The X's are independent. So you make, if you were trying to remember which one it is, you are the independent person making a choice about something. You're the X. Okay. You're part of the domain. When you make that choice, a range is created. It is your output from whatever you put into the equation that you're doing. So with our example a minute ago with the teddy bears, X would be the number of teddy bears bought, Y would be the amount of money you're spending on those number of teddy bears. So X is the number of teddy bears, it's the input and it's independent. You make that choice of what to put in. Y is how much you have to pay the person at the counter for those number of teddy bears that you chose. They're the output, the Y values. And it is dependent on what your X is. You can't have a Y without an X. Okay, you can't get a Y unless you've had an X. Okay, things to remember. Both domain and range are found by moving along the axis from negative to positive. So for the domain, that means move from the left side of your screen to the right side of the screen along the x-axis, and you're following what the x's are doing as you're moving left to right. So when you start moving across and the first thing you see is an arrow, that means you're at a negative infinity. And then you keep moving across and you get to another arrow, that means you're at positive infinity. So you're moving left to right along the horizontal line of the x-axis. The range is moving from the bottom of your screen to the top, the bottom of the y-axis to the top of it. And again, as you move up the graph, up that y-axis, if you come to an arrow, that means you're at negative infinity, and you get to the top of it and you find another arrow, you're positive. And wherever it is, you could be at a number starting, and the rest of the graph looks like it's growing from that, kind of like a parabola. Either way, wherever it starts from the bottom, that's the beginning of your range, and wherever it goes at the top, that's the top of your range. Okay, and again, the range is on the vertical, the top, the tall part of the T, not the part that goes across. Okay, so we're going to do a couple of examples of identifying domain and range from various things. This is a table. So people asked Pete, asked 5 people their ages and the number of times per month they ate fast food. If the data collected is considered ordered pairs, what is the range of the data? So we have to decide which one is the independent and which one's dependent. Well, first of all, he asked them what their age was. So he's trying to say that the number, their ages, is the independent, therefore the X, and the number of times per month they ate was the dependent, which is the Y. So we're looking strictly at this, the number of times side for our range. Range again means Y. So anytime you're looking for range, write Y right above it. And here is the range. And now, so what numbers do we have? Well, we always want to list from least to greatest. Okay. And it did not say whether or not it had to be interval notation or inequality notation or set notation. So we're going to look for any of the ones that would work, whichever one works the best, and lists out these numbers. If there are repeat numbers, like there are two 20s in this list, we only have to write it once. We only have to write the same number once. So what's our smallest number in this small list of numbers? 10. What's the next number? Well, 12, then 20, and then 24. So which of these says those those four numbers? Now, it's also important to note these are distinct numbers. They're like dots on a page. There's nothing between them. It didn't say between 10 to 12. It said 10 and then 12. It said distinct numbers. So that takes out the inequalities of B and D out immediately. We know that it's not going to be either one of those because this isn't a line. There's no lines here. There's just distinct numbers. Now, which of the other two is it going to be? Well, 10, 12, 20, 24, or 18, 23, 26, 50. So which one is your choice? And A was the correct answer. Okay, so given the data and give the domain and range of the relations shown in the graph. So again, you have to decide, one, is this lines, which means continuous, or is it dots, which means discrete? Discrete means that there are a bunch of dots on the screen, and that means you're making a list of the data of the set, or is it a line, which means you're having some kind of an interval notation or inequality notation? So in this case, we have 1, 2, 3, 4, 5 dots. So now we want to find the domain. So a domain, again, you're going to move from left to right, starting at the negative infinity, and move across until you see your first dot. And that will tell you your first domain. Okay, so the last question for ours is for the given graph, select the graph and then identify the range using the same notation. So here is a graph that has a restricted domain. We call it restricted because it is a line graph, but we only want it between these two numbers. So what you'll need to do is look for the graph that has -8 as the starting point and 8 as the ending point. But remember, -8 is less than or equal to, so that's going to be a different type of hole than 8. Also, I want you to note that the scales on each one of these graphs is not 1, 2, 3, 4, 5. It's 0 to 4 to 8. So when you're doing your assignments, be aware of the scale on the graphs because they do change. Sometimes there's ones counting by one, sometimes they're counting by two, sometimes in like this case they're counting by fours. So which of these graphs has a domain of -8 to 8? If you chose C, you'd be correct because at -8 it says less than or equal to, which is a closed hole, and then at +8 right here you have an open hole. Now what is the range? Well, again, you're going to start from the bottom, move up until you hit your first dot. Where is that and what kind of hole is it? And then keep on going until you hit your second dot. Where is that and what kind of hole is it? And when you're looking at it, we want to use the same notation. So what kind of notation did they use? It was inequality notation. So therefore our range needs to be in inequality notation. And the range is between 1, and we can guess that because it's basically closest to 0 and not quite halfway, so there's 1, and it is less than because it's open hole. Then we move up and we get to 9, which is 1 above 8, and it is a closed hole, so it's less than or equal to. It's also important to note that whenever you have a inequality where the x value is between two numbers, we always use the less than signs on both sides, less than or equal to. We never use the greater than signs when you're doing that. Okay, that is it.